Okay. So if you wonder what's gonna be on the test, I mean, if you do your homework, it should be fun. The problem is like people don't do homework and you don't know what's gonna be on the test. Um, for sure, inverse derivative. Like you are definitely gonna have like one or two questions. Kelly, Kelly, if you know what's gonna be on the test, inverse derivative. That for sure. That yeah, like that. We practiced yesterday. Yeah, and that's for sure. It's gonna be on that. Um, and I posed a homework question, couple question the day before. I think we went over the x over ln of x, finding inflection point and extremas. You gotta be able to do that. So, find extrema and finding extrema and finding a inflection point. I think the function I give you to is x ln of x. I don't know. It could be the other way around or whatever. Yeah, so you gotta be able to take a derivative, low d high d low, and stuff like that. You gotta be able to do integration using natural log. So ln, like integration of du over u. Um, and you are more likely have something to do with long division. I love long division problems. You have to do long division first. You might have some back substitutions, back subs um, using the ln situation. Um, it's not gonna be hard test. It's just all the AB integrals. So trig integrals, what inverse trig integrals. You're for sure gonna have that. You did that 2 homeworks ago. It just integration using arctan, arcsin. It might be combination of both, which is that one I like, sine inverse over square root of y minus x squared. That one's a really good one. Remember, change everything in terms of u. Um, inverse derivative. Definition of integral, I might put on that one more time, but just not gonna go through the whole definition. You just have to figure out what's the integral of that. So, definition of integral, right? You can do all that. Um, and just different variation of e to the x, integration of e to the x. Uh, of course, with u substitutions, right? So it could be splitting, could be, integration of a to the x dx. Also, we have a couple homework question, 2 homework question with a to the x. So it's nothing abnormal. So basically, in this textbooks, it's all chapter 5. And then, huh? A to the x? Yeah. 1 over ln of a to the x plus c. Oh. Okay, so 1 over ln x. No, 1 over ln of a. Yeah, plus c.
But it's like a question of like, I know it's not exactly curve sketching, but kind of similar to that. So when we want to find the horizontal asymptotes, we bring x approaches infinity.
And negative infinity.
Yeah. But like, so what if it's a like non-function? Like what if it's like xy plus y squared? Like do you bring, that was like a question I had. Do you bring 2 variables? Like would you bring, do you understand what I'm saying?
Like more likely if you have 2 variables, more likely it doesn't have a horizontal tangent. Like if you look at like uh like um,
like if you have like, I don't know, xy plus y squared, like that graph.
Okay, so let's look at what is that graph. Yeah. What is it gonna be say?
Xy plus y squared. I think that'd be kind of weird.
Yeah, but you cannot. You had to xy minus y square.
Sure. Yeah.
It doesn't form a function. It has to equal to some.
Equal. Yeah, sure.
Equal to 1. Yeah, it doesn't have. Um, I guess in this case you still can solve for y, but
Yeah, like can you do limit as x and y approach infinity? Like would that do something? Can't do both because one is dependent.
yeah, I don't.
Or limit as like x and y approach one or something. That if you can. Just like weird. What would you do?
Hmm. The problem is like anything is right because one is dependent on the other one. So you can say x approach. You still can say x approach infinite, but how would you do it algebraically? I don't know. Because x is depends on the y is dependent on x, right? So
Yeah.
you still look at x approaching infinity. What would I give y? What kind of changes the y is going to have? So it's probably still the same thing, but I don't know how you get done with two variables.
All right, yeah, so if you could do limits on those.
I don't know. So I would like to go over the second part. The second part is just this part for Jared because Jared never seen it before. But the only thing that you never sing is this is only part that's hard is the exponent rule, and it's not even hard. It's just like understanding. Um, so for Jared, should be pretty easy. So we're gonna start with first question. The first question says dy dx is equal to 6x squared y. And if you separate it, the problem you want a dy and dx on numerator. So dy, this is already on numerator, so I'm gonna move the dx to the other side. So this dx is on numerator, so I'm gonna divide by both sides by y, so it'll be dy over y, integration of 6x squared dx. And if you integrate that, it's gonna give you a natural log of y plus c equal to x cubed 2x plus c like this. Jared, this is no problem, right? So I'm gonna e to the both sides, so e to the ln y, e to the 2x cubed plus c. Now e and ln cancel out, that's gonna be y equal to e to the 2x cubed plus c. Now, this is the only part that has a plot twist. A plot twist here is gonna be e to the 2x cubed times e to the c, because that's addition, right? So that becomes multiplication. And e to the c, this just another c. So it becomes c e to the 2x cubed. So this is the original equation without, this is not a particular solution because you had to plug in initial condition. So I'm gonna plug in 4 equal to c e to the 0, which is 1, c is equal to 4, y equal to 4 e to the 2x cubed. And that is the integration. So the only time in this one is c is not adding to the functions now. C is in front of function because due to if you e to the both sides, that becomes e to the c. And e to the c will change to become a c. And that's the only thing that you haven't changed. So you got rest of the questions here for today's homework, which is all the way to question 12.
Can you go over that one more time?
Which part?
Well, first, what did you? Is this based off the first question, or is
Yeah, I went based out of the first question.
Where'd you get e to that?
Oh, because I want to get y by itself. I want to solve for y. The only way to solve for y is using inverse idea, which e and natural log are inverse to each other. So you can e to the both sides. And e and natural log cancel out.
How does
That makes sense. So then how does e to the c become c?
E to the c is just a constant. So constant can multiply by 2, it's still c, right? The c is only defined after you plug in the initial condition, which is your coordinate. That's how you fixate the graph, right? So e to the c, we can just say, well, e to the c, just another constant. That becomes e to the c, just some type of number. Now it becomes multiplying, not adding to it. Because e to the c, I could just write down this c, some type of constant. Because e to the c, just imagine c is 2. Then it's e to the 2. E to the 2, would that be a constant still? So that's a question you should ask yourself. If that's e to the 2, then just write down e to the 2. But in this case, it's actually just 4. Because I plug in initial condition, I find out that's 4. So that means e to the some type of number is equal to 4. Okay. So you got some homework question. They are, I think, 2 to 3 questions out of 6 is something to do with e, but the other one is our old practice. I think 10 or 11 has, yeah, 10 and 11 is. Question 12 is actual FRQ questions from 2012. So it turns out there was 3 questions like this. One is this one, and the following one's a potato question. I'm also gonna post as today's homework, which is a potato question. And as well as last year has a milk problem. I know everybody complained about milk problem. That was a differential equation as well, just like potato questions. I don't know. I haven't seen the milk question yet, but I assume they are very similar because everybody told me that's okay. It was okay. So you can start working on it right now, and I'll post the potato question now.
You guys took the 4.6 for that, right?
Yeah.
You took the 4.6. The one that was on Simpson.
Oh yeah.
You took it?
I forgot.
How bad is it?
I remember it wasn't too bad. Everything like right now.
Wait, how bad is it if you weren't in class most of that week?
Good luck, bro.
Good luck.
Normally, really just clutch it.
Yeah. So many graphs in that. Yes.
Day really is 2 weeks after the test.
You think it's you?
Yeah. I was just too lazy to look at it. But where's my phone?
I really think that I took with Nick yesterday, just about the Mario Brothers. Shit, right. That's probably the hardest fit I've ever like composed.
Dude, what actually? Yeah, that's something.
No, 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 no.
Do you think you would just like plug in?
Oh yeah.
Yeah.
You wear a wig? No. You brought out like a
Wait,
Wait, wasn't it this year?
Yeah, you're
Yeah.
Yeah.
Did you go to that guy's house?
It's ten then.
That one was that?
I think it would just be 0. Based on
Whose house did they go to?
Oh, the one in
Guys, get to work.
he's born. But no.
I think equals 0.
So I posted a potato question in this part of the homework. So potato question and the milk question supposed to be very similar. And that was the hardest question from last year.
So it has to say yeah.
You can't graph this. Yo.
3D decimal set. Play with it.
Oh, really?
Yeah, you go to the decimal website, they actually have a 3D decimal set. It's crazy.
So I was talking about this, yeah.
This would make sense for some two variables, because it's not equal.
But you can be like equal to them. Interesting.
You can plug in 0, 0.
Yeah,
So
so
you plug in infinity, infinity, 0 indeterminate. Third page,
that's weird.
and fourth, third and fourth, and answer that.
Just, yeah, for the ones that were like word problems that were asking for like random danger population and stuff, what is K?
K is some type of constant. So like, have you taken physics this year?
I'm taking physics one.
Good luck.
What's happening? Yeah, bro.
AP Physics 1. You know what you're doing? Okay, so for example, like a K is some type of constant. Just like think about Hooke's law. Do you ever learn Hooke's law?
We just learned Hooke's law.
KX. Negative KX.
Yeah, so it's some type of spring, right? Depending on how strong the spring is. Like if you just say if you pull if you use a spring and you pull like 2 kilogram weight, it's gonna extend a certain length. And you put 4 kilogram, it's gonna extend a certain length. But they are proportional. And that's a proportional constant. Because if I change the different type of spring, that K is gonna change. So each K is only represent that particular type of spring. So K is gonna be for that situation, it's gonna be like population growth, it's gonna be K. Now, population growth in Africa is gonna be different than population growth in Japan. Japan, nobody's having babies. But in Africa, people have babies everywhere. And people also die a lot more in Japan. In Africa. So their birth rate is higher, their death rate is higher. But it's not what you look at it. And then so the K is represents on that particular country.
Yep.
In Japan. So Japan has a very low birth rate. It's also great death rate too. Because everybody lives to 120 in Japan.
Like, what am I eating?
People die long.
You know what it is? No one does.
Like it's kind of sad.
Don't look this. This is over the. I take a picture.
And who wrote that?
This is Bryce.
Who is Bryce?
I think they left it up for our class.
You want to look at it? See? Sure.
He used to get a thing that he has to answer.
You can like look around.
He's giving y'all problems that he doesn't know he's doing it right.
This question is on the AP book. You guys show me one. I look at this problem. I also looked at a problem. Water Lewin also did the same thing.
I'll watch it. Yeah, because I need to read it.
It's just so.
That was even an I think he was copying off of something.
No, he copied off from the textbook like you guys.
So no, he
the
doesn't.
yellow one.
He doesn't know.
The yellow one.
How much hell that was
Huh?
Well, he
It was.
Charlie take a while to suck here.
Yeah, but he not.
Wait, Charlie passed with 3 or
4.
4? Somebody passed with 5, right?
I think Xavier. I bet he.
Oh, Xavier is really good.
I bet he probably.
Xavier is like a.
Try hard.
Yeah, he's bright, but he's not as smart as Bryce. But he will put in all kind of effort. He will stay after school until 7 until you pick up. Yeah, Xavier is one of. He will be one of the students want to figure out how everything works.
Yeah, no one knows how. Like Bryce kind of knows, but again, he was probably. So it's a complete mess.
Not sure.
A movie. What's good movie right now?
Good movie right now?
Has Marvel coming out yet?
mean, I heard some are saying it's good, some are saying it's bad.
I haven't seen Oppenheimer yet. Anybody seen
Me too,
Oppenheimer?
I need to see it.
It's out on a.
It's so long. I had to watch it twice because the first time I went with Ty and Bryce,
This is pretty good.
and then the second time I went with like my friend group, and we were so like we were tired because we had just come out of Barbie and we wanted to like double feature, so we went to see Oppenheimer afterwards. And
Almost like 5 hours.
dude, I wanted it was such a long.
Is Barbie a good movie?
It was better than Oppenheimer.
Really?
You should watch it. I think you'd enjoy it.
No,
Oh,
Barbie
not-
is actually.
I would not enjoy
You should watch
Barbie.
it with your wife.
I don't think she'll enjoy either. She
What about your
doesn't.
kids?
No.
Alright.
I don't want to see Barbies.
It's a good movie.
How is that good movie?
Most of the movie is about Kent. It should be called Kent.
Do they have a black kid in there?
Yeah.
They do.
There's a couple.
Yeah.
Black.
Oh, yeah.
And an Asian Kent.
There's an Asian kid. Now I have to go see it.
Yeah, Steve.
Because the most Ken are white.
And they have like a fat Barbie.
A fat Barbie.
They have a pregnant Barbie. Like
Okay.
Like, option.
Do they have Indian Barbie?
No,
Oh, represent. Oh,
it's fine.
They don't have a brown one yet.
Yeah. I don't really care. It was a good movie. It was pretty